In this lesson, we're now going to focus on Table G, which is called Solubility Curves. Solubility, remember, is the amount of solid that will dissolve in a given amount of solvent at a given temperature and pressure. So we're talking about how much can I dissolve. Table G shows the number of grams of a substance that can be dissolved in 100 grams of water. So it's a very specific amount of water that we're talking about how much we can dissolve into. And you'll see that the temperature ranges from 1 degree Celsius to 100 degrees Celsius. Each curve represents the maximum amount of substance that can be dissolved at a given temperature. Basically, the amount that allows the solution to be saturated. So all lines that show an increase in solubility, which is every single line but 3 of them, shows that this increase in solubility as temperature increases, those represent all solids. However, there are 3 lines that slope downward due to a decreasing solubility as temperature increases. And if you think back to concept earlier in this unit, we talked about how gases have a decreased solubility as temperature goes up. So if we look at the chart, we have HCl, that's a gas because it's sloping downward, NH3, and then SO2. So those are 3 gases that are shown on Table G, and you can indicate them by their lines sloping downwards. All right, so figuring out the degree of solubility. The goal of this type of question is to figure out, based on the criteria they gave me, is that describing a saturated, unsaturated, or supersaturated solution? So at 50 degrees Celsius, a saturated solution of KNO3, that should be a 3 there, contains, let's see what happens. I'm going to go to 50 degrees Celsius. I'm going to go up to the potassium nitrate line. You can see it's indicated up here. And then I'll go over to the y-axis to find that that is 85 grams, around there. So if a saturated solution contains 85 grams, you can tell by this red dot, if a potassium nitrate solution has 70 grams dissolved, what would we consider it? So when we look at where 70 degrees is, we can see it falls below the line, so it holds less than what we would expect, which we call it being unsaturated. So if it's holding less than the amount of grams to be saturated, it's unsaturated. If I have instead 100 grams dissolved, indicated by the purple dot, what would it be referred to as? Well, since it is saturated at 85 grams, if I have 100 grams of it, then we would say it's holding more than what it should, so that's supersaturated. So in general, when you're given a set of criteria, if it falls on the line, we would call the solution saturated. Below it, because it's holding less, is unsaturated. Above it, it's holding more, so it would be supersaturated. All right, now I just want to show you a couple of examples that go along with this. What type of solution is 100 grams of water, which holds 40 grams of KCl3 at 30 degrees Celsius? So we're looking at 40 grams of KCl3 at 30 degrees Celsius. So if we go up from 30 degrees Celsius and we see where that intersects the 40 grams, and we look at where the line is for KCl3, we can see that that dot is above the line, so we would say that it's going to be supersaturated. All right, we can also look at which compounds would be most or least soluble. So in this case, we're looking at which of these 4 would be most soluble at 70 degrees Celsius. So I'm going to look where each of their lines are, and you can see I've color-coded them. And the highest line would be NH4Cl, or ammonium chloride. That would be the most soluble. If I say look at 10 degrees Celsius, and now I move these over to 10 degrees, the most soluble one we can see then now becomes NH3. Okay, so another thing that you can do with those. That wasn't in the notes, but something you should know. All right, determining the amount that can dissolve. So this says, what is the solubility of potassium nitrate at 50 degrees Celsius in 100 grams of water, which is important. So I just kind of simplified this with this chart where if we just go up, we did this earlier, and over, we get about 84, 85 grams in 100 grams of water. These aren't in your notes, but if you can just listen and pay attention to how I'm getting this. At what temperature will the solubility of potassium nitrate be 50 grams per 100 grams of water? So I want to know, if I have 50 grams, what temperature must potassium nitrate be at? So I'm going to go over to the line, and then I'm going to go down, and that gives me the temperature of 30 degrees, or about 32. All right, at what temperature will it be 100 grams per 100 grams of water? So if I go up to 100 grams and I go over to potassium nitrate and then down, I can see it's about 57 degrees Celsius. So one type of question you should be able to answer. Now this question is basically doing the opposite. It says how much ammonium chloride must be added to 100 grams of water at 70 degrees Celsius to saturate it. So I'm going to start at 70 degrees Celsius. I'm going to go up to the line for ammonium chloride. That's the point of saturation. And then I'm going to be going over and finding that it's about 62 grams that would have to be added of the ammonium chloride. All right, now, all of these examples we've been doing only talk about the amount of water being 100 grams. So if you have more or less than 100 grams of water, you're going to have to take some extra steps. So you would always want to use table G to figure out your amount of solute that's in 100 grams of water. You could use a proportion if needed to determine the grams of solute per however much water you have. And then this will give you the grams of solute for any given amount of water. So for example, if the solute is dissolved in only 50 grams of water, that's half as much solvent, so half as much solute would be dissolved. If they said instead that you have 200 grams of water, which is double the amount of water off the table G, then you would simply double the amount of solute. So for example, I could use table G and see that how much HCl can 50 grams of water at 20 degrees Celsius hold. So I'm going to start at 20 degrees Celsius. I'm going to go up to HCl. Okay, then I'm going to go over. And what that's telling me is that 72 grams of HCl could dissolve into 100 grams of water, but I only have 50 grams of water, which means I'm going to divide both numbers by 2 and get that 72 divided by 2 is 36. I would have 36 grams of HCl and just 50 grams of water. You could also set a proportion that 72 grams of HCl is in 100 grams of water, so how many grams of HCl would be in 50? Simply just cross multiply and divide to solve for x, and you'd arrive at the same answer of 36. Alright, so those are a bunch of examples of table G.